let's take care of some polynomials theorem. The first theorem is the remainder theorem. So it's pretty much state that if the remainder theorem, so we're looking for the remainder. So if you have the values, in this case right here, you can see that the values is 3. So pretty much if you take the polynomial, the given polynomial, and you divide by x minus 3, so P of C is of the form x minus C. Okay, so if you take the polynomial, you divide by x minus C, then P of C is going to be the remainder. So that's the theorem. So what can I do? I can use synthetic division and divide. So I have 3. And don't forget the synthetic division. We use all the coefficients. So I have 1, negative 2, negative 5, 0. I have nothing for x, so I have to put 0 in, and 6. All right, so 1. I just copy it down, right? 3 times 1 is 3. Negative 2 plus 3 is 1. 3 times 1 is 3. And then I have negative 2. 3 times negative 2, negative 6. Negative 6. 3 times negative 6 is negative 18. And I have negative 12 here. So you can see that the remainder is negative 12. Therefore, P of 3 is going to be negative 12. Okay, so that's the remainder theorem. Now, the remainder theorem is related to the factor theorem. So the factor theorem, pretty much if you do the division and if you get 0 for the remainder, that means we have the factor, right? So very simple. 3 is a factor of 12 because if I take 12 divided by 3, I get 4. No remainder. So that's the idea behind factor theorem. So you see right here we have x plus 3. Okay, so I'm going to perform the synthetic division. Don't forget is negative 3. You put negative 3. Why is that? Because x plus 3 is x minus negative 3. Okay, so 1, 2, negative 5, 0, and 18. Okay, so same thing. I write down 1 because I just bring it down. Negative 3 times 1, negative 3. Negative 1 here. Negative 3 times negative 1 is 3. Negative 5 times negative 5 plus 3 is negative 2. Negative 3 times negative 2 is 6. 0 plus 6, 6. Negative 3 times 6, negative 18. And we get 0 for the remainder. Therefore, we know that this is a factor because we get 0 remainder here. So this is a factor. Okay, and if I put P of negative 3, I'm gonna get 0 because that's the remainder. All right, so we're gonna use the same idea for number 20. So number 20, they give you 1 as a 0. So I know that x plus 1, x minus 1 is a factor. So I'm gonna use that one and perform synthetic. So I have 1, 3, negative 2, negative 2. Okay, now don't forget because x minus 1 is a factor, when you perform the synthetic division, we better get 0 for the remainder. 1, 1. 3 plus 1, 4. 1 times 4, 4. Negative 2 plus 4, 2. 1 times 2, 2. Negative 2 plus 2, 0. Okay, so now I'm ready to write the linear equation. So which is x squared. Remember, this is x cubed, so 1 less is x squared, plus 4x plus 2. Okay, I can, if you can factor, that would be great. You can't factor, you can complete the square. I'm going to complete the square. Okay, or you can use quadratic formula. So because a is 1, so that's why I think completing the square is going to be easier. -2. So I complete the square, I add 4. Why is that? Because 4 divided by 2 is 2. 2 squared is 4. I add 4, so I add 4 on this side. X plus 2, so we factor. We get 2 here, right? So what I have is I'm taking the square root. I'm taking the square root here. So x plus 2 is plus and minus square root of 2. So my solutions are x equals to -2 plus and minus square root of 2. Okay, now I'm going to write all the factors. The first factor I have is 1. So x minus 1. And then from there, I have x minus -2 plus square root of 2. And x minus -2 minus square root of 2. Okay, so we have 3 solutions. Okay, now rational zero theorems, pretty much you list all the possible rational zeros. Pretty much you have all the factors of a naught. This is a naught. And all the factors of an. This is an. So I'm going to write it down. In this case, a naught is 5. An is -7. So if you list all the factors, right, all the factors of a naught is going to be plus and minus 1, plus and minus 5. And then we have plus and minus 1, plus and minus 7 for an. Now, all we have to do is take and then pair them up, right? So I have the factor of a naught over the factor of an. So I'm going to do the easy one first. So I'm going to get, so I get plus and minus 1 over plus and minus 1. So that's 1. And then plus and minus, sorry. And then I have plus and minus 5 over plus and minus 1, which is 5. Okay, so I did 1 and 5 for 1. Now I'm going to do 1 over 7 and 5 over 7. So plus and minus 1 over 7, plus and minus 5 over 7. Okay, so you can go any methods that you want, as long as you cover all the factors, then we're good. Okay, so those are the possible rational zeros. Now, Descartes' rules of sign. So how do we do that? For positive, we're going to keep that positive and you look for the change in sign, right? So I'm just going to copy this is the positive one, right? So you can see that how many times we go from a positive to a negative or a negative to a positive. Only one time, from a negative to a positive here. So only one time. We have negative, 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 then we change to positive. So possible numbers of positive real zero is only 1. For negative, you want to plug negative in. So nothing changed here, because if I have if I raise to the even power, nothing changed. I raise to the odd power, it's going to change. I raise to even, it's not going to change. Odd, yes, it's going to change. And then constant, stay the same, right? So now this time, let's count. We go from a negative to a positive to a negative to a positive. So you see we have 3 times changes in the sign. So the possible numbers of negative real zeros, 3. But because it's 3, you can take away 2. So the possible could be 1 as well. So we either have 3 possible numbers or 1 possible number. Okay, so I know it's kind of confusing. anything that bigger than 2 or 2, you can just take away 2. So let's say if I have 4 changes, then the possible would be 4 and 2 and 0. So you keep subtracting 2. If I have 5, that would be 5 or 3 or 1. Okay? All right. Now, number 23. So the function has at least one rational 0. We're going to use it and we're going to find all the zeros. So what I have, I can use the rational theorem. So the rational theorem, you take a naught, divide by a n, right? But I'm going to do the easy one. One possible would be 3 over 1, right? So how about I try 3? Now, if 3 is not right, then we go back. We try negative 3 or we try 1, right? But anyway, let's try it. How do I know if it's a right number? If I get 0 for the remainder, then I know 3 is a 0. So 10 here. 30, negative 3, negative 9, negative 1, negative 3, 0. Bingo. So 3 is a 0. Okay, so from here, we have 10x squared minus 3x minus 1. I'm going to try quadratic this time. So we have b, negative b plus and minus square root of b squared minus 4ac over 2a. Okay. So what I have is 3 plus and minus square root of 40, 49 over 20. Oh, okay, so 49 is 7. Square root of 49 is 7. So 3 plus and minus 7 over 20. So I have either 10 over 20, which is 1/2, or negative 4 over 20, which is negative 1/5. I should have tried to factor instead of using the quadratic formula. But anyway, you see that we have 1/2, negative 1/5, or 3, and 3. So these are the 0. Okay. So once again, from the beginning, from the 10x squared, this one, you want to factor, go ahead factor. I thought we couldn't factor, that's why I try it. I try quadratic formula. Okay, so multiply here. Before we multiply, I just want to remind you one thing. I squared is negative 1. Why is that? Because square root of negative 1 is I. Okay, so keep that in mind. All right, so let's multiply. Let's FOIL, right? So we have x squared minus x times 2 minus 6i negative x 2 plus 6i. I have to do it slowly because I don't want to make mistake. Plus 2 plus 6i times 2 minus 6i. Okay. So what we have right here, you see that we have the conjugate. So I'm just gonna take care of I'm just gonna simplify something first. So 2 plus 6i times 2 minus 6i's. This one right here is the conjugate. So if you multiply by the conjugate, hopefully you still remember, it's just 2 squared minus 6i squared. But I squared is negative 1. So it's turned into a positive 6. So 4 plus 6 here, this is 10. Okay. So what I have is x squared minus minus 4x I have 6i squared right here, so it should be 36. I'm sorry. So this one should be 40. Okay. Let me put it right here. So 36i squared, which is turned into a positive 36 plus 4 is 40. So that's going to be the final answer. Okay. All right, so for number 25. For number 25, what we have the degree 3 with the real coefficient and the following zeros. So what I have is x plus 3, that's 1, 0. That's take care of the negative 3. Now, for the complex, every time you have a complex 0, the conjugate is also a 0. So you have to include the conjugate as well, which is this one. Okay, so that's going to be the polynomial. And of course, you have to multiply it out. Okay, so for number 26 here, similar to what we did before, they give you a 0. So I'm going to use that 0 and use synthetic division to find the other zeros. So if I don't make any mistake, I should get if I don't make any mistake, I should get 0 for the remainder. In this case, it's right. Okay, so I have x squared minus 6x plus 13 equals 0. All right, for sure you can't factor, right? So I'm just gonna use I'm gonna complete the square. Every time I have a equals 1, completing the square is way easier than quadratic. So plus 9 here, because negative 6 divided by 2 is 3. 3 squared is 9. Okay, so if I take the square root, I take the square root. I ended up with x minus 3 plus and minus 2i. Okay, so it's going to be x equals to 3 plus and minus 2i. Now I'm ready to write the factor form. So x plus 3, x minus 3 plus 2i, and x minus 3 minus 2i. Okay, those are the zeros.